Okay, students, in the previous session we did two cases for Sn. One is r is equal to 1 and second one is r is less than 1. Now we will take the third case number 3, that is if r value is greater than 1, common ratio is more than 1, then what happens to the formula? Okay. So here, whatever there in the last session, same thing is there here again. What you do for r greater than 1 also, do the same thing. Multiplying r to the equation 1. What happens to that? R into Sn is equal to r into a plus ar square, so on, up to a into r to the power of n minus 1. R into Sn is equal to, r is getting multiplied with all these, ar square, ar cube, so on up to a into r to the power of n. Let me take this as equation 3. To get the formula, what you do? Take the operation taking equation 3 minus equation 1. Equation 3 is r into Sn is equal to ar plus ar square plus ar cube, so on up to a into r to the power of n. And first term is Sn is equal to a plus ar square, so on up to a into r to the power of n minus 1 it is. As I am subtracting, change the sign here. Left hand side I have r into Sn minus Sn, and here this ar square, ar cube up to a into r to the power of n minus 1, all those terms becomes 0, subtracting the corresponding terms. In this first series, what is left out? A into r to the power of n left. And what about in the second series? In second series, a is remaining, that is minus a as it is. Okay, Sn is common in the left hand side. Sn into r minus 1 is equal to, here a is common, r is to n minus 1. Sn is equal to a into r is to n minus 1 by r minus 1. This is the formula. When we should use this? We should use this formula when r greater than 1. Means common ratio is greater than 1. Otherwise, you will get some negative values. That's why. So better use this r greater than 1 and r less than 1 cases properly, depending on the value of r. Okay. Now we will go to the problems on geometric progression. Let me take the examples here. Example 9, page number 187, that is NCERT textbook. Example 9 says, example 9, find the 10th and nth terms of the GP, terms of the geometric progression 5, 25, 125, so on. That is the geometric progression given to us. We need to find out what is 10th term and what is nth term in that. Okay. Given GP is 5, 25, 125. What is the first term here? First term a is equal to 5, and what about the common ratio? Common ratio r is nothing but a2 by a1. R is equal to 25 by 5. 5 ones are 5 5s. So answer is 5. Common ratio is 5 here. 5. What about the 10th term? To find out the 10th term, we will use nth term formula. In case of nth term of arithmetic progression, an is equal to a plus n minus 1 into d was there. In the same way, in geometric progression, we have nth term an is equal to formula a into r to the power of n minus 1. Simple formula. What is our question? Our question is to find out the 10th term. 10th term means n is equal to 10 here. Okay. 10th term, that is a10 is equal to a into r to the power of 10 minus 1. Nothing but a into r to the power of 9. Okay. a10 is equal to, we have a10 is equal to, substituting the values of a and r, a is 5 into r is also 5 to the power of 9. This is nothing but 5 to the power of 10. 10th term of the geometric progression is 5 to the power of 10. Now, second question, what is that? What is nth term of the GP? Nth term means I have to find out an, that's all. An we need to find out. An is equal to general formula a into r to the power of n minus 1, that is already known to us. Now, an is equal to, a is first term, that is 5, r is common ratio, that is also 5 to the power of n minus 1. This is nothing but 5 to the power of, bases are same, nothing is there means 5 to the power of 1 it will be. Here dot means it will be multiplication. 1 plus n minus 1, 5 to the power of plus 1 minus 1 get cancelled, 5 to the power of n, that is nth term. Central term of this geometric progression 5, 25, 125, so on. That is about the example number 9. Okay. Now we will take the next example, that is example 10. Example 10, which term of the GP, which term of the GP GP given is 2, 8, 32, so on, up to n terms, is 131072. Okay, which term of the GP 2, 8, 32, so on up to n terms is 131072. What are the given terms here? Our GP is given, GP is 2, 8, 32, so on. Using this GP, what are the terms we can write? We can write the first term a, that is nothing but 2. We can write the common ratio, that is r is equal to a2 by a1. R is equal to 8 by 2. 2 ones are 2 fours are. We have r is equal to 4. Common ratio is 4. First term a is 2. Which term andre yava pada ee geometric progression alli yava pada 131072 ageti anta ನಾವು calculation ಮಾಡಬೇಕು ಇಲ್ಲಿ. Okay, this is an is equal to given to us. An is 131072 and n, which term we need to calculate, you know, so n is equal to question mark here. Fine, nth term is given to us. Use the formula an is equal to a into r to the power of n minus 1. Substituting the values, an is nothing but 131072, which is equal to a is 2 into 4 to the power of n minus 1, r is 4. Okay, 2 I can take to the left hand side. 131072 divided by 2 is equal to 4 to the power of n minus 1. Okay, 2 ones are 2 6 are 12, 1 remains 11, 5 are 1 remains 0, means 5 are 3 are and 6. This is 65536, which is equal to 4 to the power of n minus 1. This is 4 to the power of n minus 1. This term, left hand side term also, you should try to write 4 to the power of something. 4 to the power of something you should try to write. Check it. 4 to the power of 8 is 65536. 4 to the power of 8, which is equal to 4 to the power of n minus 1. It is there. Both equal to symbol is there. Both side bases are same. 4 to the power, and this is also 4 to the power. So the exponents has to be same. 8 is equal to n minus 1. Then what is n is equal to 8 plus 1. N is equal to 9. Means ninth term of the GP, ninth term of the GP is 131072. 9ನೇ ಪದ 131072 ಆಗೈತಿ ಅಂತ ಕ್ವೆಶ್ಚನ್. Going to the next question, that is example 11. Example 11, what it says, in a GP ಅಂದ್ರೆ ಒಂದು geometric progression ಅಲ್ಲಿ the third term is 24, the third term is 24 and the sixth term is 192. Find the 10th term. Find the 10th term. Okay, our question is to find out 10th term here. 10th term, what will be A10? A10 is nothing but A into R to the power of 10 minus 1, means A into R to the power of 9. Okay, A into R to the power of 9. A and R are the two unknown quantities I need to calculate here. First of all, for that we will use the given data. What are the given data? Third term is 24. Third term is 24. What is third term of a GP? GP ಅಲ್ಲಿ third term ಏನ್ರಿ? GP ಅಲ್ಲಿ nth term A into R to the power of n minus 1. ಅದೇ ರೀತಿಯಲ್ಲಿ third term in the sense n is equal to 3 here. So that is nothing but third term means A into R square. A into R to the power of 3 minus 1, that is A into R to the power 2, which is equal to 24. Let me take this as equation 1. And next they are saying that sixth term is 192. Sixth term is equal to 192. What is the sixth term in our GP? Sixth term is A into R to the power of 5, which is equal to 192. Take this as equation 2. To solve for equation 1 and equation 2, two equations are there and two unknowns are there, A and R. We will solve those two. Okay, to solve for equation 1 and 2, what you do? You take equation 2 divided by equation 1. Left hand side it will be A into R to the power of 5 divided by A into R square, which is equal to 192 by 24. Okay, A get cancel, R 5 times here, here R 2 times. 2 times we can cancel R, we left with R cube in the left hand side. And right hand side what happens? You divide it by 12 2s and 12 1s 7 remains 72, 12 6s 72. Okay, 2 1s 2 8s, R cube is equal to 8. R cube is equal to 8 can be written as a 2 cube. Therefore R is equal to 2. See, I will tell you one thing here. In 9th standard you have studied, if the highest power is 3, then it will be having 3 roots. If highest power is 2, it will be having 2 roots. If highest power is 4, it will be having 4 roots, like that. Here highest power is 3 for the unknown. It is also an equation, but we are writing only one root. What about the other 2 roots, sir? Here Other two roots will be imaginary roots. That one we will study in the chapter complex numbers. Okay. So that will be imaginary roots. That one we will not consider. Only real root we will consider. Real root is 2 here. Fine. R we got. And what about the A? First term is, to get the first term, you substitute in any one of the expressions. Let me substitute in equation 1. Equation 1 implies A into R means 2, I am substituting 2 square, which is equal to 24. A is equal to 2 square means 4. This is 24 by 4. 4 ones are 4 6. A is equal to 6 we got. Now it is very easy to find out the 10th term. 10th term, that is A10 is equal to A into R to the power of 10 minus 1. A10 is equal to A into R to the power of 9. A10 is equal to A and R values. Right now we have calculated. A is 6, R is 2. 2 to the power of 9. 6 into 2 to the power of 9 is 512. You should remember that. Now 512 into 6. 6 2s are 12, 1 carry, 6 1s are 6, 7, 6 5s are 30. So A10, 10th term of the geometric progression is 3072. Okay, with that example number 11 completed. Going to example number 12. What is example number 12? Find the sum of first n terms. Example number 12. Find the sum of first n terms. Find the sum of first n terms and the sum of first 5 terms and the sum of first 5 terms of the geometric series 1 plus 2 by 3 plus 4 by 9 plus so on. Geometric series is given here. With this we need to find out sum of first terms, means sum of first n terms Sn, and sum of first 5 terms S5. So here what is first term? Here A is equal to 1. What about the common ratio R is equal to? That is A2 by A1. 2 by 3 divided by 1 is nothing but 2 by 3. So R is equal to 2 by 3. Directly we can go to the formula for Sn. Sum of n terms is equal to sum of n terms, that is Sn is equal to R value using 2 by 3 means less than 1, 0 point something for the 3. R is equal to less than 1 in the sense you use the formula A into 1 minus R to the power of n divided by 1 minus R. Sn is equal to A is 1 minus of R value is 2 by 3 whole to the power of n divided by 1 minus 2 by 3. Sn is equal to 1 minus 2 by 3 whole to the power of n divided by 1 minus 2 by 3. If you cross multiply, this becomes 3 minus 2 by 3. It means 1 by 3. 3 will come to the numerator. Sn is equal to 3 into 1 minus 2 by 3 whole to the power of n. Very simple one. This is what Sn. Sn indicates sum of n terms general. If you substitute n is equal to 10 here, it gives us sum of first 10 terms. If you substitute n is equal to 20, it gives us sum of first 20 terms. In the same way, what they have asked you? They have asked you sum of first 5 terms of the geometric progression. Okay? Sum of first 5 terms. Just you substitute n is equal to 5 here. So we have S5 is equal to 3 into 1 minus 2 by 3 whole to the power of 5. That's all. We can leave it here, or else we can simplify. 3 into 1 minus of 2 to the power of 5 by 3 to the power of 5. S5 is equal to 3 into 1 minus 2 to the power of 5 is 32, and 3 to the power of 5 is 3 to the power of 4 into 3, 3 to the power of 4, 81, 81 into 3, I can write 3 and this is 24, 243. Okay, let me simplify that answer. S5 is equal to, sum of first 5 terms is equal to 3 into cross multiply 243 minus 32 divided by 243. 3 into 243 minus 32 is nothing but 211 by 243. 3 ones are 381s are. This is 211 by 81. Sum of first 5 terms. If they have a common factor, we can cancel it again. Thank you.